we will try to find the following limits of this function f of x defined by ln of x minus ln of x. Okay, so this is a composed function. The first step that we have to do is that we need to find where we can work. We want to find the limit as x goes to infinity, but what is this function is defined. Okay, so the first condition here is that we need to have, okay, so finding the domain of f. Okay, so the first condition here is that we need to have x bigger than 0. And from here, we need to have these two conditions as well. We need to have x bigger than 0 and ln of x bigger than 0. Therefore, we can have this condition, x bigger than 0 and ln of x is bigger than 0. Okay, we can solve this condition graphically. Okay, so we know that ln of x can be graphed this way. So here we are looking for x bigger than 0, we are here, and ln of x bigger than 0, that means ln of x bigger than 0 when x is bigger than 1. So this condition is satisfied when x is bigger than 1. Therefore, the domain for our function is 1 plus infinity. Okay, so we need to be careful of that. The next thing is that now we have this one, okay, defined it's positive. And this one is defined is positive. If we try to compute the limit, okay, we see that this one is infinity and this one infinity inside, but we have plus infinity minus infinity. So we can't conclude. We need to do more work to be able to find the limit. Okay, but there is a crucial idea that we need to notice. So we know that ln of a over b is ln of a minus ln of b. So we're going to use this one here. With a is x and b is ln of x. So this is a crucial idea to rewrite this function. So let's do it. So we have f of x is ln of x minus ln of x. So given the condition that x is bigger than 1, we have ln of x over ln of x is the right one. So we use this fact here, okay, when a and b are positive. So therefore, we have our function here. Now we're going to use one key idea. So we know that ln of x is continuous for x bigger than 1. Okay, now to find the limit, so the limit of f of x as x goes to infinity is the limit of ln of x over ln of x. Okay, so this limit here exists. Okay, x over ln of x as x goes to infinity, and the natural log is continuous, so we can enter the limit inside. So we have the natural log of the limit of x over ln of x as x goes to infinity. What about this one here? What do we know about that? So this one here is a fight between the power and the log, and the power always wins. Okay, so this is infinity, and therefore the log of infinity is infinity. Okay, check the video for these ones. Which one wins, the power, the log, or the exponential? There is a video about this one here, one of the videos that we have done for this case. So anyways, so we proved that the limit of this one, okay, is infinity. Now we're gonna find the limit, the other limit that's left. So the limit of f of x as x goes to 1 from the right. Okay, so here we can just use this one here. So when x goes to 1 here from the right, we get 0. But here, when x goes to the right from here, we get 0 plus. And the natural log, when we get close to 0 from the right, is infinity. is minus infinity, and with this minus it's plus infinity. Okay, therefore this limit is plus infinity. Okay, it's clear. We just need to pay attention. We don't need to use this formula, okay, because here it's clear. We don't have a problem when we plug 1 from the right. We just need to be careful and remember what happens when we plug 1, okay? So therefore, the limit from the right as we go to 1 is plus infinity, and the limit as x gets bigger, it's plus infinity, okay? And I think that's it. Now, if we want to graph the function, okay, what can we do, okay? We can use derivatives. One f is positive, one f is negative. Okay, it's up to you. You can do more work. Okay, using derivatives will complicate the work, but we can do it. It's not that bad, but graphing the function without any derivatives is easier.